Welcome to Mobile Math, Math Lessons on the Go. Today's learning goal, by the end of this lesson, I should be able to multiply double and triple digit positive numbers together using the distributive property of multiplication. And again, we'll be doing this without the use of a calculator. So quick reminder, multiplication is a shortcut for repetitive addition. When we use the word product, that is the result of multiplying numbers together. So product, multiply, times, those all come from the same family of multiplication. So I'll put this warning out there right now. Some of the problems shown here using the distributive property may be very challenging. You may find the area model with friendly numbers a better strategy to use. So when you encounter these types of problems, work to your strengths, but don't be afraid to explore some new ideas and concepts. So let's see if we can push ourselves a little bit today. We've seen this model already, 4 times 13. So I've done the area model. I've broken the 13 down into the 10 and a 3. So I have two groups. I have one area of 40 and one area of 12. We add those together, we get 52. When we look at the number model, again, we've broken the 13 down into a 10 plus 3. And the actual distributive part comes from when I multiply that 4 into each of those terms. And when we see this 4 times 10 here, that is the same as this piece on the area model. And the 4 times the 3 is the same as the second piece or the second rectangle on the right there. And we have a 40 plus a 12 again to get the same result as 52. So that's a bit of a warm-up for our number model and our area models. So the first example we're going to look at today is going to be a little challenging in that this is the first time we've ever split up both numbers with the distributive property. We've done this before in the area model. So the 18 becomes a 10 plus an 8. The 25 becomes a 20 plus a 5. And you can see in the area model very clearly there are 4 distinct numbers, 4 regions. That's one of the powers of the area model. It's very visual. You can see where the numbers come from. The distributive property, it's a little more challenging, but let's go through it and hopefully we can see where everything comes from. So when I go to distribute these two numbers, the first distribution will be a 10 times a 20. And you'll notice over here on the area model, there's the 10 times the 20. The second piece will be 10 times a 5. And again, over here on the area model, there's the 10 times a 5. I'm just going to change colors here. The second part of the area model, or the distributive property, will be 8 times a 20. And there it is on the area model. And lastly, I have 8 times a 5, which is this piece over here on the area model. And when I multiply those all out, you can see them written here. I'll eliminate these for 1 second to make them a little smaller. On the third line here of the number model, you can see all of those multiplications happening. And when I actually evaluate those products, I have 200, 50, 160, and 40, which are the exact same numbers that showed up in the area model. And when I add those all together, I end up with the same result of 450 for both models. So let's continue with that idea. So this time we're going to use some larger, oops, jumped ahead again. I'm going to use some larger numbers here. So I'm going to multiply 28 times 85. So I'm going to break down the 85 into an 80 plus a 5, the 28 into a 20 plus an 8. Now these are pretty big numbers. I'm using larger numbers just because of space issues on the smartboard. You may have to use smaller numbers to get some of these in the area model. That is completely fine. It will work with distributive property as well. It just gets a little bit more messy and challenging. So let's just go through this quickly. So 20 times 80 would be my first distributive property, and you'll notice over here on the area model, there's the 20 times 80 for 1,600. The next piece on the distributive property would be 20 times a 5. Over here on the area model, there's a 20 times a 5 or 100. We'll switch back to blue for a minute here. 8 times an 80, that is this bottom corner over here on the area model, or 640, and 8 times a 5 is the final corner. There it is, a little messy. And that gives me the final piece in the distributive property. So my third line down again shows all of the multiplications. My fourth line down right here, you'll notice all of those numbers match up with the 4 numbers over in the area model. And when we end up adding those all together, and again this may take you a line or two extra to add these all together using some friendly numbers, I end up with 2,380 as my final result. So our final example, hopefully it doesn't skip too far ahead. Hooray. We're going to multiply 24 times 15, but I'm going to do this a little differently. I'm going to break up the 24 into even smaller numbers. And this might be overkill for this particular question, but I want you to see how the distributive property works. When we look at the area model with friendly numbers, my 24 has become a 10, and a 4. My 15 has become a 10 plus a 5. So now if I was to fill in the area model, I would have 10 times 10, or 100, for the first two, followed by a 10 times 4 for 40 in the top group. And then the bottom row would be 5 times 10, or 50, and I would have to do that twice. And 5 times 4 is 20 for the bottom piece. So I've filled in my area model as if it was a new and fresh problem, which we haven't seen before. When we come over to see our distributive property now, here's where we have to take our time. I'm going to have a 10 times a 10. So there's one of them. A 10 times a 5. There's the 10 times a 5. I'm just going to change colors. My next will be a 10 times a 10 again. Well, there it is. And another 10 times a 5. Well, that's on the bottom. And you can start to see how this pattern forms. My last group will be a 4 times a 10. There it is. And a 4 times a 5. For the final piece of the puzzle. So when I multiply this out, I actually end up with 6 terms that I have to add together, but they are smaller, a little bit more manageable. Again, you may prefer the area model for this. That is completely fine. Use whatever model works best for you. And when we sum this all, we sum up the second last line, I get my final product of 360. So if you'd like to take a moment, press pause on the video and try the following. If you want to use the product rule, or the distributive property, pardon me, please break them up as you see fit and go from there. Okay, welcome back. So let's tackle these two problems. I'm going to break down the 65 times 74 into 60 plus 5 times 70 plus 4. So I should end up with 4 terms on the next line after I do my distribution. So I'm going to have 60 times 70, and that gets me 4,200. 60 times 4 is an additional 240. I'll change colors here. 5 times 70 is a plus 350. And lastly, 5 times 4 is plus an additional 20. When I add all of that together, I come up with a grand total of 4,810. And again, it may take you a few more lines to do this. That's completely fine. We'll do our last example here. I am actually going to leave the 80 alone. I think I'm happy with that one, but I might break down the 120 into 2 parts. So as I distribute 80 times 100, I end up with 8,000. And 80 times 20, I end up with 1,600, and when I add those two values together, I get 9,600 as my final result. Thank you for watching. Please watch again and pause where you may have had difficulties, and good luck in your future math problems.